Hello, Kirchhoff's law for AC circuits, level 2. And about the only difference between level 1 and level 2 is at level 2 you have to pay a bit more attention to the direction of the arrow on the ammeter or the voltmeter. In this case we have 8 milliamps at minus 45 degrees flowing in this way, 7 milliamps at 135 degrees flowing out this way, and an unknown current flowing in there. Well, since the total current flowing into the node, that would be the unknown current I, plus the 8 milliamps at minus 45 degrees, must equal the total current flowing out, which in this case is 7 milliamps at 135 degrees. We could just write, well, the unknown current here must be this current here minus this current here, which is 7 milliamps at 135 degrees minus 8 milliamps at minus 45 degrees, which is about 15 milliamps at 135 degrees. And we could just type that in here and we'd be done. If I didn't have a calculator able to do complex numbers, which you won't in the exam, you'd have to do something like looking at this and saying, okay, organ diagram. 7 milliamps at 135 degrees is going to be out in this direction here, because that is 135 degrees, and it's going to be a distance of 7 milliamps. That's the phasor representing this current here. And then this one, 8 milliamps at minus 45 degrees, well, that would be 45 degrees clockwise because it's negative, and that would get us to here, and this is 8 milliamps, so it would be 8 milliamps in this direction down here. What you might notice is that these two phasors are completely opposite. If I want to take the 7 milliamps minus the 8 milliamps here, I would be doing the 7 milliamps up there minus the 8 milliamps means carrying on from that point in the other direction, in exactly the opposite direction from this one, but for a distance of 8. Well, the opposite direction to this phasor is just carrying on up here. Another 8 milli, so we'd end up here 15 milliamps at 135 degrees, which is the answer that I got. Try voltage 1. Here, same type of problem actually. You'll notice this voltage source, however, is upside down. In other words, this point here is 110 millivolts at 90 degrees higher than that point there, and this point here is 110 millivolts higher than this point there with a phase angle of minus 90 degrees. A couple of ways you could do this. You could instantly note that inverting a voltage source, turning it upside down, is the same thing as moving the phase through 180 degrees. And therefore, if I took this 110 millivolts here at 90 degrees, turned this upside down, what I would end up with is 110 millivolts at minus 90 degrees, which is exactly the same as the voltage source I have here. So the total voltage between there and there would be 220 millivolts at minus 90 degrees. Alternatively, I could say that going from here to here minus going from here to here must be the same as going from there to there, because this is going from negative to positive, so we've gone up by 110 millivolts at minus 90, and this is going from positive to negative, so we've gone down by 110 millivolts at 90 degrees, and that would give me the answer. Right, here I've got one where the current flowing in is unknown. I have 1 milliamp at 0 degrees flowing in, and a total of 15 milliamps at minus 45 degrees flowing out. So simplest way to do it is just to take the total current flowing out, 15 milliamps at minus 45 degrees, subtract the known current flowing in, 1 milliamp. I don't have to write at 0 if it's at 0, just 1 milliamp as a real current will do, and that's it. Another one here where I've got 1 microamp flowing in at 135 degrees, 7 microamps at 180 degrees flowing out, and this flowing out. Since I've got a calculator that can do complex numbers, I could just work that out, since the output here must be the input current into the node minus the other output current from the node. So the answer must be 1 micro at 135 degrees minus 7 micros at 180 degrees, and so on. Just use the complex calculations, and these are quite straightforward. Gets a bit harder at level 3 when you're no longer allowed to use complex arithmetic.